Hello, and welcome to this review of how you can use satellite imagery to track changes in land cover and for lots of other things as well. This presentation was prepared for the Fall 2025 Citizen Science Symposium sponsored by the Ridges Sanctuary in Bailey's Harbor, Wisconsin. Let's start with a disclaimer. Your presenter is not an expert in satellite imagery, land cover tracking, or pretty much anything else. He's just a citizen scientist, so you can take whatever he says here, or anywhere else for that matter, as a grain of salt. That being said, if your presenter can do this stuff, so can you. Given that, the primary purpose of this overview is to raise awareness of the potential for citizen scientists with a modicum of computer skills to use satellite imagery to track land cover changes. In this presentation, we will cover why you would want to do this, where you can get satellite imagery, what you can do with satellite imagery, and what steps you might want to take next given what you see here. So, why satellite imagery? As we know, natural climate change and human activities are altering the environment in which we live, and especially vegetation land cover. Any efforts to alter the course of these changes at either global or local levels should include the ability to monitor the changes. For whatever time and resources that we are expending to mitigate these changes, are we actually making things better? This is where satellite imagery can be helpful. Free satellite imagery is readily available to citizen scientists involved in climate change monitoring and mitigation projects. Great! So where can citizen scientists get all of this free satellite imagery? There are a number of satellites providing such imagery, but in this overview we will be using Landsat data that provides high-quality images every 16 days with 30-meter spatial resolution. We will be downloading data from the Earth Explorer web portal that is managed by the U.S. Geological Survey. Earth Explorer offers free access to all Landsat data and provides various filtering options for time, location, cloud cover, and more. You do need an account to use Earth Explorer, but it's free and just takes a moment to do. We should mention that if it happens that Landsat and or the USGS just disappear one day, the EU Copernicus satellite system can also be used to obtain satellite imagery. Copernicus does have global coverage, better resolution than Landsat, and flies over more often, but it is a bit more challenging to use. So for now anyway, we'll go with Landsat and USGS. For this demonstration, we will use the USGS Annual National Land Cover Database. As we will touch on later, there's lots of other types of data available through Earth Explorer, but the annual NLCD data should whet your appetite for using satellite imagery. To get the NLCD data, go to Earth Explorer, log in, and click Clear Search Criteria to get a fresh start. Now pan around the map until you get to your region of interest, here, Northern Door County, Wisconsin. Then go to Search Criteria, scroll down the search criteria until you get to the Circle tab and click on it. Now click on the middle of your region of interest and then click on the outer edge of your region of interest to specify your satellite image search region. Now scroll back up and click on Datasets. what you'll see is a whole bunch of interesting data sets. We are going for land cover and the annual NLCD collection. You can learn all about the collection by clicking here, but we'll go right to getting some data. With our land cover dataset selected, scroll down and click on Results. After a moment, we should see what Earth Explorer has found. Fortunately, this looks like our area of interest. Now click on the download icon, click on Download, and save the download. Opening the zipped download, we see data from 1985 all the way through 2024. To date, that's 39 years of data. It's the TIFF file images we are interested in, so opening up the 1985 image, for example, we see this nicely colored map of our region of interest, which we can zoom in on to see some detail. Okay, so what are we looking at? Well, here's the region we zoomed in on, and here's the NLCD image, but what do the colors mean? The 16 land cover classes fall into 8 major categories for water, developed lands, barren land, forest, and shrubland, and herbaceous, planted and cultivated, and wetlands. So, using these designations, this is what our zoomed in map is showing us about land cover in our region of interest. The region appears to be mostly mixed forest, deciduous forest, pasture and hay, and woody wetlands. Now at this point, you might ask yourself, how did they do that? Satellites like Landsat have sensors tuned to different spectral wavelengths. Landsat in particular captures images at 11 spectral bands. This is a table of the Landsat spectral bands with an overview of the characteristics of each band. The land cover images that we are working with are derived by combining typically bands 2 through 7 to highlight various land cover types. Just FYI, the next version of Landsat, should there ever be one, will have sensors for 26 spectral bands, thereby enabling much finer resolution of land cover types. We can see some changes in land cover from 1985 to 2024, so that's kind of cool, but really, so what? Well, using GIS tools like QGIS, we can do some interesting quantitative analysis on our imagery. For example, we can calculate the change in coverage of various land covers over a period of time. So here, in our 40-year survey of our 526-acre region of interest, we see an 8-acre increase in developed land, a 19-acre increase in forested lands, at the expense of a 27-acre decrease in open and farmlands. Here we have extended this analysis to all of northern Door County for the period 1985 to 2024. Again, you can detect some changes, but quantitatively, we see increases in developed land and forested areas, which came at the expense of farmland and open land. Beyond land cover per se, Earth Explorer provides many other types of environmentally oriented data. Two that you might find of particular interest are the vegetation monitoring datasets and the phenology datasets. The Normalized Difference Vegetation Index, or NDVI, is used to measure vegetation health and density and is widely used in agriculture, forestry, ecology, and climate science to monitor plant growth, drought conditions, and land cover change. As for the phenology datasets available through Earth Explorer, here are the types of phenology-related measures that you can access. As you can see, these data can be helpful indicators of natural climate change and human activities. And if this area of citizen science really intrigues you, you might want to check out my Satellites for Amateurs tutorials on how to do the type of quantitative analysis that we saw here. Finally, please note that this work would not have been possible without the generous assistance of staff at the USGS Earth Resources Observation and Science Center. If you have questions on how to use Landsat data, contact their customer service. All Landsat data used here, courtesy of the U.S. Geological Survey. Thanks for watching this video. Hopefully it will be useful to you in your citizen science efforts.